Welcome to Ask and Learn.
Question number 12 wants us to determine the acceleration of a particle using a graph of its position and velocity. I've illustrated the graph from our textbook in relation to this problem here. As you can see, the points illustrating the particle's velocity at a certain position follow a roughly linear fashion across the chart. The trend line only has a slight curve to it. The particle's position is denoted by the letter S, and its velocity by the letter v, and we're asked to determine what the particle's acceleration a is when we're at a position S of 20 feet. We can figure this out by using the definitions of velocity and acceleration. We define velocity as being a change in distance with respect to time, so we can think of v as being equal to ds over dt, the change in the particle's position over the change in time. Acceleration, meanwhile, is defined as being a change in velocity over time, so we can think of a as being equal to dv over dt by that same logic. We're not given time as a variable here, but we can use these two definitions to work around that. If we take our acceleration and divide by velocity, using these two definitions we'll get dv over dt divided by ds over dt, or dv over dt times dt over ds. That allows us to cancel out both the dt's, and now our expression for a over v is equal to dv over ds. dv and ds are actually found using the constraints of our graph. dv is the extent of the velocity charted, which is 8 feet per second, and ds is the range of positions that is charted. Our particle is at a position starting when it's at 10 feet away, and then it's charted until it's at a point 30 feet away. So ds is going to be equal to 30 minus 10. That means that dv over ds, and by extension a over v, is going to be equal to 8 over 20. So now we have our expression for acceleration. We can just rewrite this to say that a is equal to 8 over 20 times v. So all we need to do now is find our value for v when s is at 20 feet. If we look at our graph and find the point on the chart where we're at a position of 20 feet, and just follow right up to where we find one of the little points, we find that v has a value of approximately 3 feet per second when we're at a position of 20 feet. So our acceleration a will be equal to 8 over 20 times 3 feet per second. When we multiply that out, we get 24 over 20 feet per second squared. When we divide 24 by 20, we get our final answer of 1.2 feet per second squared for this particle's acceleration when it's at a point 20 feet away.